This is Scott from KIG. It's March 29th, 2016, and we're going to do a couple videos today on this 2012 ChillKing 7.5 ton dual circuit chiller. This particular unit, for our testing and runoff, we can have all the side covers off because it is a sealed area here on this two-fan condenser. This unit, again, is a 2012. It's the model GC090CK3. The 90 stands for 90,000 BTUs at nominal chiller temperatures. We're going to go ahead and just power the unit up, and in this one case here, we're just going to do a few redundant things, just confirming what the electrical requirements of this unit are. And then while it's starting to chill, I'm going to go around and talk about a few different things on the unit also. So these are outdoor rated units. The controls and the electrical are all within this sealed cabinet door, which should be on. To turn the chiller on, all you do is come over to the toggle switch here, turn it up, or turn the switch up to turn it on, and that basically activates the pump. In this case here, we just have a single pump drawing off the tank, and that's a 1 horsepower pump on this particular unit. We're going to talk about the Ranco controller a little bit. On this dual circuit, dual compressor chiller, what I'm going to do today is a couple different things, but first we're going to take this tank of glycol, which is about 30 or 40% glycol, about 55 gallons, and we're going to chill it down to about 28 or 30 F with both compressors on, and I'll talk about that in a bit. When we've been testing it over the last week, we've actually been running it through this air handler here, which creates about a 3 or 4 ton load, just to help us get some additional run time in this shop testing setting. The nice thing about the ChillKing chillers, or any chiller using a Ranco, is how simple it is. When it's been sitting for a bit, it's just going to show you what the temperature of the fluid is, in this case 70. You simply press set, and then we go into mode for cooling 1, or the compressor 1. We leave it at F for Fahrenheit. We press set again, and that gives us the set point for stage 1. Press set again, that gives us the differential. So it's going to go up 2 degrees or maybe higher until the compressor turns on again and cools it down to the set point. You press set again, and that's C1. You don't want an H1, you want to leave it in C1. That's cooling mode 1. Press set again, and now we're in the second stage, which happens to be at a 72 set point. You press set again, we're at the differential for stage 2. Set again. We're in cooling mode 2. Don't do it in an H2. And you press set again, and that's going back to what the temperature of the water is, or in this case, the glycol. So I'm going to start changing these right away. I'm going to bring both of them down to actually 28 in this case. So I'm going to press set, Fahrenheit, set. I'm going to bring it down to 28. Set. I'll leave the differential at 2. Set again. I'm in cooling mode 1 confirming. Now I'm going to cooling mode 2. I'm going to bring it also down to 28. Now the right thing to do is, when you have 2 compressors, is have the set point the same, but have the differential a little bit higher on the second one, and you can alternate back and forth. I'm going to have the differential on this one at 3, okay? I'm going to press set again, cooling mode 2. Set again, it reverted back to what the process fluid water was, and you can hear both my compressors started. Now the idea of having the set point the same for both compressors is we're going to chill down, okay? Now as the set point rises, I'm sorry, the compressor's going to turn off when we meet the set point or set points. So now our temperature will start rising a bit. When you get 2 degrees above the set point, in this case, compressor 1's going to turn on. Now if compressor 1 can't handle the load, it's going to creep up a little bit. In this case, we'll let it creep up 1 degree above, because we have a 3 degree differential, and then the second compressor will turn on also. That's the best way to do it to get good efficiency in staging. And then over a period of time, you can alternate between circuit 1 and circuit 2 as to which has the slightly higher differential, just because one compressor will be working more often than the other. But a real simple controller. This unit here, and by the way, we know both compressors are on because you can see that the contactors are both clicked in. Now this unit here is a 208 230 volt 3-phase unit. It's a 4-wire connection, 3 hots and a ground. Okay, there's no neutral wire required. The control circuit is taken care of with the controls transformer that we see right there. So we're going to go even one step further here. Just to show you exactly what we mean for this particular customer. Now, our shop electricity, our low voltage actually is about 204 volts. That's a little bit low, but it runs fine on that. Anything from 200 to, just below 240, the unit should run just fine on. I'm going to take my meter here. So, in this type of 3-phase power, we've got it on AC. Between each hot leg, and you should have a licensed electrician do it, of course, only. Actually, we're even a little bit lower today. We're at 202 volts between the top two. 202 volts between the bottom two. 202 or 203 volts between the top and the bottom. So between any hot legs, you should be measuring your 3-phase voltage. In addition to that, each one of these legs to ground should measure 115. There's my ground wire there. 117. 117. 117. Okay? So again, a 3-wire connection, 3 hots, and a ground, making it a 4-wire connection. You do not need a neutral for this type of 3-phase power. So we got both compressors running now. We're starting to chill. We're down to about 67 in this case. Now we have an insulated tank. Let's check one thing here. This unit has a 55-gallon insulated tank. There's 2 circuits. Not only are there 2 compressors, there's 2 refrigerant circuits and 2 heat exchangers. This is a very small example off a little 1-ton chiller of a coil-type heat exchanger. There's 2 of them in this tank. One's actually a little bit taller and fits in the other. They both have effectively the same amount of surface area for the same amount of heat transfer. So if one compressor goes down, you still have 50% of your cooling capacity until that compressor gets fixed. So again, you got 2 heat exchangers, 2 circuits. Each one of your circuits has a high pressure switch, a low pressure switch, and a pressure switch for the fan. This has low ambient, and that's what the fan pressure switch is for. So this can run down into minus 20, minus 30 Fahrenheit range outdoors. This is an outdoor rated chiller. Now right here inside the tank, that's the float level switch. Okay, now you always want to have your fluid level up above that, and on this model that comes back to the terminal strip here, and they actually call it autofill here, but you can use it for a couple different things. There's a timer here, so you don't get any chatter, but the best thing to do, if you're running straight water, which this customer's not going to do, what you can do is actually have the autofill terminals here tie into a solenoid, so if the fluid ever gets low, you automatically add makeup water. That's not as practical if you need a glycol solution. In fact, it's dangerous if you add straight water to a glycol chiller. So in this case, what we recommend is you use this feature and tie it into a 24-volt DC buzzer or alarm. and just bring a wire into your office or into your shop. So here's our refrigerant circuit compressor number 1. We're starting to get a little bit of frost on this as we're starting to chill. Both units are running. It's about our shop temperature, our ambient temperature in here today is about 55 degrees, 58 degrees, maybe a little warmer. So as I said, both these compressors are going to be running right now. But after it meets set point and starts creeping up, only one compressor is going to turn on the way we have it set up. Here we have our refrigerant sight glass. These are R410A units. Our thermo expansion valve and the refrigerant sight glass, which you want to see nice and clean like that, or clear, I should say. Let's go over and look at the other one. Refrigerant dryers within the circuit also. So this is a 3-phase unit. It is phase dependent. However, you need to be careful when you start these up and be aware that the pump is a single-phase pump and the fans are single-phase fans. So the main thing you have to do, you have to be very careful of, is have your HVAC technician confirm that the phase rotation is correct on the 3-phase compressors. To do that, you know, the technician would put his gauges on the unit, and the way they say it here in the label is this: if the compressor is noisy and the pressures are almost equal when the system is running, the compressor is operating in the wrong direction. And that is true. But on the initial startup, have a HVAC technician here just to confirm the rotation. The last thing you want to do is run those compressors in reverse, and some people can make the mistake if they see the fans rotating in the right direction that everything is hunky-dory. That's not the case because it's single-phase fans and a single-phase pump. Your fluid connections are on the outside here, and we have we put a shut-off in our little test circuit. We're not running the air handler right now, but we do put in a flow meter. And you might be able to see, yeah, you can see, we probably got it adjusted at 20 GPM, maybe a little bit less. This pump's capable of more. If I open the, I'm opening up the shut-off more. And now you can see we're up to 30 or 40. But I'm going to bring it back down into a more, what I think is a more reasonable range. Back down to the 20 GPM area. This is just loose for now. This is your vent and also your fill. We'll connect that back up before shipping here. We went ahead on this particular application and added all new Armaflex insulation to the tank, the top of the tank. We also lifted it up and put additional insulation in on the bottom. So we'll come back with our video number 2 in a bit here as we get closer to our set points. Thank you.